Hi everyone, welcome to Jackie Does Stuff. I'm Jackie and I do stuff, and today I want to show you how I am going to test power cables using a volt-ohm meter. So come on and check it out. So here we have a pile of power cables. The power cables are the ones that have the two prongs and the grounding prong, the three prongs here that plug into the wall. And then they have another side where you plug another device into. These also are like that. Some of these come from laptops, I think. They have the prongs, and then on the other side they have something you plug the device into. I have a lot of electronics that need to be tested, but I just thought I would start with these for now because these ones are fairly straightforward. So these are all power cables. This is an extension cable, or I guess it's a power splitter or whatever you want to call it. And this right here is what's called a volt-ohm meter. And I can get into all of the stuff that this does later, but for now, all you got to know is that it's testing for something called continuity. And continuity means does power go from here to there or from there to here? And you would do that by putting these two prongs, one on one side and one on the other. And then there will, here, this number should be, or a number will appear on the screen, and that number should be pretty close to 0. And I'll explain what that means as I get everything set up here. So I'm going to just pick one of these cables. I think maybe I'll start with this one because you're likely to have seen this before. I'm going to take one of these two. Now, the black one is what's called the ground, the grounding probe, I mean. And this is where the power would go to. So this one I'm going to want to put kind of in one of these holes over here. Hello again, it's Jackie from the future. Sorry to cut in. I just wanted to say the thing that I'm about to show you with the color of the probes, the black going in one place and the red going in the other, for the thing that we're testing for, resistance continuity, that is the placement of the red and the black. That's what's called polarity. That doesn't matter for resistance. The thing is, though, is that it super matters if you're measuring voltage. So that's not what we're doing here, but it's a good habit to get into because you could really mess up your whole day by putting them the wrong way around. Anyway, back to it. Bye. And then the red one, oh goodness. So the black one, the black one is also called the negative probe. And the red one is called the positive probe. And that's basically like where the power would start. So it's kind of like, if you imagine that these two probes are kind of like hanging out here, you know, in like a mad scientist lab where they'd have kind of like the shock jumping from one to the other, you know, like Dexter's lab or something. So you would imagine that the power would start at the red one and jump across to the black one. So the power travels in that direction. It travels from positive to negative. So with this power splitter, that would mean that the power would start over here at the wall side, and then it would come out in here. Now what I'm going to do before I get those set up, I suppose, is I'm going to take my volt-ohm meter and I'm going to turn this dial toward this sort of horseshoe looking symbol. Now this is the Greek letter omega, which symbolizes this unit called an ohm. That's where the volt-ohm meter comes from. And we are just going to set this to the lowest number, 200, right there. There we are. Now see, some numbers have showed up on the screen there. We are picking the lowest number here because if this is working, if this is functional, then there will be what's called continuity, which means that the power will freely be able to travel from its start to its end without anything impeding it. Now, if something is going to get in the way of it, that's going to be a big problem because it shouldn't. It should go right from here to there with nothing in between. But if something were in between, that is something called resistance. And that's what the ohm measures. So basically for this little test, what that means is that the higher the number when we probe our cable, if the number is much higher than 0, that is not what we want. We want the number to be pretty close to 0, and that means that there is almost nothing resisting the flow of electricity, and that's what we're looking for here. So if the number is pretty close to 0, that means that the cable is good and we can use it. That's what we're testing for here, is just to make sure that these bad boys work. And if they don't work, we're going to go ahead and put them in e-waste, which I'm very lucky to have in my town. And if you don't have it in your town, a lot of Staples stores will pick up e-waste as well, so you might want to get in on that. If you were curious, this sort of 1 symbol here, this basically means when you have it set to resistance, to ohms, that means it basically has an infinite amount of resistance, and it's measuring the space between these 2 probes here. So because they're not touching, because there's air in between these 2 probes, that, as far as the probes are concerned, that might as well be an impossible amount of distance between the 2. But as we bring them together, as we touch one to the other, we see the number gets lower and lower and lower. And I'm not touching it perfectly, that's why the number is jumping around like that. But it goes essentially to 0, to pretty much 0. So that is within our comfort range. I could accept that that is a 0 right there. If the number was like 200 or 250 or 1,000 or some like really, really high number, that is bad, and that is not what we're looking for. But pretty close to 0, that's pretty much 0 as far as I'm concerned. Yeah, so now I'm going to go ahead and I'm going to test each of these ports here, and I will show you how I do that. All right, so it's a little difficult to do this with only one hand, but I will go ahead and give it a shot. So we're going to take the negative probe, and we're kind of just going to pick one of these 2. We're going to have to do both. You'll see why in a second. But yeah, we're going to get the probe way down in there. Now, this is not plugged into a wall or anything, so I'm not worried about getting electrocuted or anything. But yeah, you definitely want to be very careful with these if you are actually going to be testing something with voltage, which I'm sure you will at some point if you do use one of these. So I have the negative side in there. Now, I don't know, because I'm not an electrician or anything, I don't instantly know which of these 2 probes or which of these 2 prongs directly connects to this one. So I'm going to touch both with my positive. So I'm going to turn this over so that I can see it a little better. There we go. And these have holes in them, which makes it a little easier to do this test. So I'll touch the probe to this top one here, and I'll get real good contact there. And the number's not changing, so that's probably not the right one. So I'm going to move the probe down to the other one. Oh, there we go. All right, and I'm going to just try to get really good contact. I'm going to press on there. Okay, and we're at like 1. Like I said, that's not 0, but it's not, if it were like 100, that would be a problem. So I'm going to call that good. That's good. So I'm going to take this out now, and I'm going to take the negative and move it over to the other side. Now, we know now, since we have already done that, this top one should correspond to that. There we go. All right, now let me get the probe in the hole, and no, and touch. Okay, and that's less than 1. So that I'm going to call a success. Okay, so now I'm going to test all the rest of these, and I'll go ahead and speed it up for you. All right. So it looks like this power splitter is functional, at least for that test that I was running. So that's good. So these are all cables that I have just accumulated in my electronics pile for a little while. So I'm finally trying to get a little bit of sense made about that. So now that we know that this works, I can put that aside and I can go ahead and get started on these other ones. So I will see you in a moment. All right, so it looks like all of those power cables are in good working order. At least they don't seem to be broken. There seems to be continuity. That's good. So it looks like I can put these in the keep drawer for now, and I can go ahead and test some other electronics later. Oh, and when you're done with your volt-ohm-meter, you're just gonna go ahead and turn it off. And I always like to take my probes out of it and then kind of like tie them separately up, like store them separately. I don't know why. That's just something that I learned in my electromechanical class. Probably because the meter that I used had like a third port and it got kind of complicated. But anyways, yeah, I hope that you found this helpful. I hope to be doing some more electronic stuff in the future. This is just something that I had a couple of minutes to do, so I wanted to show you guys. So thank you so much for watching. I hope you enjoyed, and I'll see you in the next one. Bye.